Metrics base units combine to form metric derived units. So for example, in the metrics, meters measure length, kilograms measure mass, seconds measure time, Kelvin measures temperature. You need to know this all year. So if you need to, go ahead and make yourself flashcards. Okay, a lot of time for some reason students say, oh, I don't need flashcards, I don't like them. They are so helpful. So please make yourself some flashcards, get some index cards, or just use paper, or use one of the online versions of making flashcards, whatever, but you need to know every time you see meter, think how long it is. Every time you see kilogram, think mass, how much stuff it's made of. Every time you see second, think time. Every time you see Kelvin, think temperature. Now, if you're thinking to yourself, wait a minute, I thought it was Celsius. We do use both. We use Celsius, and in science, when they're being very specific, they use Kelvin, which is named after Lord Kelvin, not to be confused with Calvin and Hobbes. But you will be actually using both Celsius and Kelvin. And I adjusted the size of the screen. Hopefully if it was a little too small before, you can see it okay now. So hit pause if you need to, and make sure you have all those written down. All right, other important stuff that you should know. Water boils at 212 degrees Fahrenheit, which is the same as 100 degrees Celsius. Water freezes at 32 degrees Fahrenheit. It freezes at 0 degrees Celsius. So you need to know these. Again, I suggest making flashcards. Write it down. Absolute zero. Absolute zero's temperature is related to the motion of molecules. Absolute zero is the temperature at which all atomic and molecular motion would stop. Absolute zero equals 0 degrees Kelvin, or negative 273 degrees Celsius, or negative 453 degrees Fahrenheit. So all of these are equal. When you have 0 on the Kelvin scale, that's minus 273 Celsius, which is also minus 459 degrees Fahrenheit. Okay, this is important. The only time scientists believe that atoms stop moving is at absolute zero. And in fact, scientists are trying to reach absolute zero, and even with all their labs and studying, they haven't quite got there. Although, maybe it's a good thing, because some scientists have said that they believe time will stop when you hit absolute zero. So maybe it's a good thing they haven't done that yet. So it's all very interesting. And if you're sitting there like, wait a minute, time's going to stop, it all has to do with Einstein and all that type of thinking in physics. So we're not going to get into it. Just kind of interesting to mention. And you do need to know the only time atoms aren't moving is at absolute zero. Okay, the next section that you need to know, your metric prefixes. Kilo, abbreviated K, means 1,000. So there are 1,000 meters in 1 kilometer. Then the multiplication factor, when I put 1, that's your bases. Your bases are meters, grams, liters. So you can have a kilometer, a kilogram, a kiloliter. You can also have the prefix centi, abbreviated C, which is 0.01. And that means there's 100 centimeters in a meter. Or a centimeter is 1/100th of a meter. As in like cent, like money, right? Like 1 cent is 1 penny. That's a good way to remember that one too. Milli is even tinier. It is 1,000th of a meter. And there are 1,000 millimeters in a meter. Be sure you know kilogram equals kg, gram equals g, milligram equals mg, kilometer equals km, centimeter equals cm, millimeter equals mm. So those are the main ones that we're going to use. And I should have added milliliters. So ml is milliliters and L is liters. We do use those a lot as well. Again, everything on this slide, I expect that you know all year. Okay, so write it down, practice it. All right, so let's go through lesson 1.16, metric system base units. So again, metric base units combine to form metric derived units. Examples, meters measure length, kilograms measure mass, seconds measure time, Kelvin measures temperature. The metric system is a scientifically based decimal measuring system. Scientists use SI or metric units, and most of the rest of the world does too. The United States, Liberia, and Burma do not use the metric system in daily life. In this lesson, you will learn about the metric system, its base units, what each of these units measures, and how metric units relate to one another. You will also learn about metric measurements of temperature and the concept of absolute zero. Goals for this lesson: distinguish between SI base units and SI derived units. Identify the SI base units. Use metric units to express length, volume, mass, temperature, and define absolute zero. Okay, so close your eyes, and because I don't want you looking at anything. Length. What is the unit for length? Meters. Okay, what is the unit for volume? Liters or milliliters. What is the unit for mass? Grams, or if you said kilograms, that's okay. And for temperature, what are our two choices we can use? Celsius or Kelvin. Okay, you can open your eyes. If you didn't know those off the top of your head, make flashcards. It's going to make the whole rest of the year easier. Okay, and so there is the study guide you can download. Decimal measurement is based on breaking a standard unit into 10. In the English system, there are 12 inches in a foot, 3 feet in a yard, and 5,280 feet in a mile. That may be easy to remember if you're familiar with these units, but it is difficult to make conversions. If you need to change your units from yards to feet, you have to multiply by 3. But if you need to convert from feet to inches, you have to multiply by 12. People have often thought that there must be an easier way, one where a standard base unit is divided or multiplied by 10 to get larger and smaller quantities. Eventually, the French Academy of Sciences developed a useful base 10 system of units called Système International des Units, SI, or International System of Units. The basis for all SI measurements is the metric system. The metric system is easy to use because it's based on multiples of 10. So if you have 0.1, you multiply by 10 to get one whole unit, multiply that by 10 to get 10 units. Or you can go the other way, divide 10 in half, divide 10 by 10, you get 1. Divide 1 by 10, and you get 0.1. So again, you can do metrics based on multiplying and dividing by factors of 10. And for about 10% of people, that works really, really good. So if you're one of those and you want me to walk you through it, I will. For the other 90% of people, I have found it's just so much easier to use the staircase and to just move the decimal to the left or to the right. And the staircase is what I K-mailed you. The metric system gained popularity after the French Revolution. During the French Revolution in 1790, the French government instructed the French Academy of Sciences to design a new, simple, science-based measuring system. They proposed measuring length based on a decimal fraction of an arc that extended from the equator to the North Pole and went through Barcelona, Spain, and Dunkirk, France. The Academy appointed two men, Jean-Baptiste Joseph Delambre and Pierre-François-André Mecon, to survey the distance. The survey took them 6 years. The Academy's standard unit, called the meter, was 1/10,000,000th of that distance. Okay, so the meter isn't a random amount. They actually used the Earth to come up with the meter. So SI uses SI base units for parameters such as length, mass, and temperature. An SI unit that is not the result of a combination of other SI units is called a base unit. Also known as the metric base unit, SI base units are the basic fundamental physics measurement. The metric system is based on a decimal fraction of the length of an arc that goes from the equator to the North Pole. If you think about it, it's actually pretty cool. They did this in the 1700s. So this is before satellites and GPS and all that stuff, computers, smartphones, which is probably why it took them 6 years to do it. The meter is the metric base unit for length. The standard meter, abbreviated lowercase m, is 1/10,000,000th the distance from the equator to the North Pole. This length was marked on a brass bar and kept by the French Academy. In 1799, the brass bar was replaced by platinum bars and later by platinum iridium bars. The platinum iridium bars were kept in many nations to standardize measurements. However, scientists sought even more rigorous methods to define a meter, especially when they realized that the Earth is not a perfect sphere. Today, a meter is defined as the distance traveled by light in a vacuum in 1 299,792,458 of a second. No, you do not need to know that number. All right, a meter. So just so you have an idea, that's how big a foot is. A yard is 3 feet. A meter is a couple of inches bigger than a yard. So if you go the distance between your shoulder to your fingertips, that's probably pretty close. Pretty close depending how tall you are. The kilogram is the SI base unit for mass. The first metric unit of mass was the gram. A gram, abbreviated lowercase g, was defined as the mass of 1 cubic centimeter of water at 4 degrees Celsius. Similarly, a kilogram, abbreviated kg, was defined as the mass of a cubic decimeter of water at 4 degrees Celsius. So a decimeter is 1/10 of a meter. There are 1,000 grams in a kilogram. Water was eventually replaced by an equivalent mass of platinum iridium metal as a standard. Blocks of the standard platinum iridium kilogram were distributed to various nations to standardize mass and weight measurement. The platinum iridium kilogram standard is kept under glass in controlled conditions, okay, so that nothing can bump it, nothing can hit it. So it's actually a really serious thing. Mass is the amount of matter. Okay, so weight is the force that gravity exerts on mass. If you take 1 kilogram of matter anywhere in the universe, the weight will change because gravities of various bodies differ, but the mass remains the same. Mass is how much stuff you're made of. Gravity pulls you down, and that's your weight. Your weight changes on the moon because the moon has less gravity. Your mass does not. The standard for temperature used to be degrees Celsius. The English unit of temperature is the degree Fahrenheit, abbreviated degrees capital F. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. However, in 1742, a Swedish astronomer named Anders Celsius proposed a different temperature scale, a decimal scale. In his scale, 0 degrees was the freezing point, typo, 0 degrees was the freezing point of water, and 100 degrees was the boiling point of water. After Anders' death, the temperature scale was inadvertently reversed by the thermometer maker. As a result, the Celsius temperature scale that we now know has 0 degrees as the freezing point of water and 100 degrees as the boiling point of water. Okay, so if that confused you a little bit, basically what Anders was saying was that what I said was a typo, right? Because I didn't want you guys thinking that 0 degrees is boiling. That's what he wanted to do. He wanted to say 0 was boiling, and then 100 was really cold, but then, even though it's inadvertently, it really makes more sense that the freezing's at 0, and then it goes up the other way. So, although I suppose if we were used to his way of thinking about it, we would say that way is more normal. So, either way, that's why I really want you to say, even though he was thinking about it the opposite of what we do, you need to know 100 degrees is boiling, 0 degrees is freezing. Formulas for converting between the two temperature scales are as follows. Degrees Celsius, so if you want to convert from degrees Celsius and degrees Fahrenheit, you either put in your temperature in Fahrenheit and say 5 divided by 9 times the quantity, degrees in Fahrenheit, minus 32. If you have your degrees Celsius and want to go to Fahrenheit, use this equation, 9/5 degrees Celsius plus 32. You will always get these on quizzes and tests. You do not have to memorize them. You just have to be able to plug in the numbers. Make sure that you know how to do that, especially with the parentheses. If you need help with your specific calculator, email me the brand and model number of your calculator and I will help you. The Celsius scale has also been called the centigrade scale because there are 100 degrees between water's boiling and melting points. Centi means 100. It can also mean 100th. The Celsius temperature scale places 0 degrees at the freezing point for water and 100 degrees at the boiling point for water. All right, so I'm going to pause there because my 15 minutes is going to run out, and we will continue on the next slide in the next video.